So in this video, we're going to go over how to do calculations for half-life. So if you're not given a graph, how can you calculate amounts or quantities or half-life itself depending on the information given? So there's two ways that you can calculate half-life. First is with an equation, and any of these equations listed here work. Those are not particularly lovely or easy equations. So if you really want to use one, I guess you can use this one. I would avoid the other two because they involve weird constants that we're not really going to talk about. But to be honest, I think the easier way is to not use an equation and just think about it by halves. So if you're going to calculate something with half-life not using an equation, you're basically going to take your amount. So whether that's counts or atoms or grams or whatever, and then you're going to multiply it by half for each half-life that the question asks you about. So for example, as this is written, if I asked about 3 half-lives, here's 1 half-life, here's 2, here's 3. Say I asked about 5 half-lives, we'd multiply by half 2 more times. So there would be 4, and then 5th half-life would be that again. And then that gets you your amount. So we're going to apply this into 2 different sample calculations just so we can kind of see how to think through these types of questions. So first example, a material undergoes radioactive decay for 5 half-lives. If the initial amount is 216 grams, how much will be left? Okay, so it's going to go, we're starting with 216 grams and it undergoes 5 half-lives. So I'm going to multiply by half 5 times. There's 1, 2, 3, 4, 5. Okay, and then I'm going to plug that right into my calculator. So 216, I'm going to type it in, making sure to follow order of operations. So I'm going to put each of my halves in parentheses. And I'm going to make sure that I have 5 halves. 1, 2, 3, 4. Sorry, I'm counting on my calculator. 5. Okay, and that got me 63 grams. So if I break it down, if I do 216 times a half, after 1 half-life, I'd have 1,008. After another half-life, I'd have 504. After my next half-life, I'd have 252. My next half-life, I'd have 126. And then my last half-life gets me my 63 answer. So that's how we'd calculate the amount remaining with no graph and just our amount and our number of half-lives. So let's look at another question. A substance has a half-life of 1.2 days. If there were 1,000 atoms to start, how many atoms will remain after 6 days? Okay, so in this case, I told you that it has a half-life of 1.2 days and it goes over a time of 6 days. So I need to figure out how many half-lives that is. So I'm going to divide those two numbers. I'm going to do 6 days divided by 1.2. So this is my total divided by my half-life. So if I do 6 divided by 1.2, that gets me 5 half-lives. Okay, so 6 days is the same thing as 5 half-lives. So now I'm going to apply the same logic that I did with the first problem. So I have 1,000 atoms to start with. And I'm going to multiply by half 5 times. So there's 1 half-life, there's 2, 3, 4, and 5. So after 1 half-life, I would have 500 atoms. After another half-life, I'd have 250. And then if I do 250 times a half, or if I do 250 times a half, I typed something wrong on my calculator and it confused me. I get 125. Again, if I multiply 125 by a half, I get 62.5. And then finally, if I do 62.5 times a half, I get 31.25, and these are atoms. So I can't have a part of an atom, so I would say I have 31 atoms remaining. Okay, so those are just two examples of how you can calculate half-life or amount of time, all depending on what information you're given is how you're going to think through these types of problems.